Okay. Well, no, I don't have a solution. It's amazing, but couldn't think of anything. So the plan is to start write a little test application, completely standalone, in which I'm going to investigate this problem. And hello again, Superman. So I'm just going to write something, I don't know. Let's call it elect. Okay, so what we have is resources and contenders. Okay. Well, let's make a class called resource. And I have another class called let's call it thread. Now we need a random number generator also. Going to brute force a few things, I guess. Just, you know, try things out. What the hell are random numbers? It's not just random, I don't know. Let's have a look at the browser. Yeah, it's called random. But we also need Grono. Do we need Grono? Wow, if you want a seed. Might as well copy this. Okay, so I guess we need Chrono. Okay, well, it's a very lengthy way to get a seed, but whatever. Use a seed for the merchant twister. I'll bet that thing has an example on the website. Some website somewhere. I want this one. very small example. Well, I guess we just call the parenthesis operator on those things, and we get numbers. This is a very, very, very meager example. Well, no, it's not normal, uniform dist. So I just use this and then pass something which can also be a Merchant twister. Okay, so that works. It generates random numbers between 1 and 6. Let's work with. So this is our random number stuff. Then we are going to create a vector of resources. No, why not an array? Well, yeah, I'm gonna fix the number of resources, I guess. Might as well fix them. Let's say, how many resources do we have? 8. That just initialize all the resources with some fixed number. So in order to keep the resources apart, I need an ID. I'm going to give them an ID like that. And make it a class. So I need a default constructor because I'm putting them in an array, and then afterwards we initialize it with some ID. That's C++ in NeoVim, yeah. I'm just going to run over all the elements, running from I equals 0, I is less than resources.size, which is 8, plus plus I, and I'm going to, on the resources, so resources I, init, I. And then the IDs are 0 through 7. Next we have threads. There's absolutely no reason to make this static, by the way. Let's say number of threads. Well, let's start with 4 threads. I don't know, it's also random. And the threads, I'm going to initialize the threads with so we have arrays. Let's initialize the threads with a certain number of resources. So I'm going to we have a uniform distribution, let's say for 3 resources, 2 resources to 6 resources. I'm just going to call this a number of resources per thread. Yeah, well, that's clear enough. I don't have to say that it is 26 in the name. Let's call these T. Could use I as well, but just a T of threads. And that runs, of course, then from... Well, might as well use a number of threads. Now I have that anyway. Let me use here a number of resources. It's just the size of the array. And I'm going to say threads. It's this array. Well, I called it resources, right? Resources I. You might, if you want to read this as English, I mean the array is plural because it contains resources. And then this doesn't read very well because it says resources I. But okay, let's keep it plural anyway. And I need to initialize that as well. And I'm going to pass, let's say, a number between 2 and 6, which is then the number of resources that this thread wants. So my thread, which I also turn into a class, wants a certain number of resources. I'm going to store that in a vector. It's a vector of resources, the resource that it wants. Resource pointers. It's the thread's trying to acquire all the resources in this vector. Same thing, we need a default constructor. Now the reason that this is blue and this isn't is because my main program defines a thread. Can jump to it even. So I have a class thread in Tracy apparently. Who cares? But of course they're just the same thing here. It's just both they are both a class. And I'm going to initialize this with a number of resources. But then it's the number of resources for this thread, not the total number of resources. That means that we want to set the size. Could say resize to the number of resources. So the size of the vector is now correct. And I want to fill them, of course. Which resource? Well, maybe I should just run over R for resource, R to the number of resources, and then do a pushback. That will also in total give us number of resources elements, after which the type is the same. We're going to push back a pointer to the resource. There's two things that I need then. So a pointer to resource number X, right? Where X is a random number. So I'm going to need a I'm going to need to pass the array. I just pass the resource pointer to our resources. This is kind of ugly programming, right? Maybe it should pass an array. Let's pass an array, why not? Array, but then if I pass array, then I really need to pass the number of resources again. Just the total number of resources. So maybe I should call the total and total number of resources. Oops. Now I'm going to move this. This must be total. And I can say, let's just Move these things, which are kind of an initialization, to the top of the program. And then yeah, well, I like the symmetry, so let's call this total number of threads. That's nice nonsense. There is only one number of threads. That's the total number. So this is the number of resources that this thread wants to acquire. And this is then the array, the global array of resources, which I pass. And I'm also passing the generator, which is a machine twister. Also as a reference. Yeah, and then I need distribution here, which is they all need to be unique. It's not entirely logical how to do that. Trivial, I mean. I have no idea. Let's Google it. I have an idea actually. What I can do is I need a vector with random numbers that is shuffled. So I make an array with numbers in it called random numbers, and then I fill it with just a sequence. And then I run over it again. And then we swap RNI with RN I think generator, and then the distribution of, well, 0 to total number of resources. I'm just calling it D for distribution. So I need a distribution. Yeah, uniform in distribution. D, which returns a number between 0 and the total number of resources. There is a standard shuffle? I didn't know, man. Ah. There's a thing I have an example. Yeah, can just do this. Thank you. Use the generator. You guys, so now I have a shuffled array with a number 0 till total number of resources, and then we need a random number No, I'm just going to run over. Well, I'll just pick the first number of resources then from that array, which you push back. So resource rn r. That looks good, I think. Let's just test it by printing out what this thing returns, okay? Looks same. So I have to my init, I have to pass a number of resources and all the resources. And my random generator, number generator. I'm a perfectionist. The modulo is said to be not very. That wouldn't be a perfect uniform distribution, as if I need it. Why do people keep asking me stuff about HTML? This is about C++. Or just download Apache, which is not in C++, I guess, but... Right, we have here now an init and it needs to be passed. Now I forgot again, damn it. Number of resources, resources generator. Like that, where then the number of resources per thread is this distribution. So we get a number between 2 and 6. And that fills it, and now I want to see the result. So I'm going to run over all the threads again. And now we're going to print whatever it contains. Thread T. Which means we must add here a thing that prints it, that is allowed, that is able to print it. Tip print standard OStream reference operator, standard OStream reference OS, comma, thread, const reference, thread. Is that going to compile? So, or is that the keywords these days? And I'm going to write something like this. And then for each element in the vector, so resource pointer. Well, let me add a print on, because I like that print on standard OStream reference instead of the str. Oops. Oh no, I forgot to include a header. Not to mention I forgot to include a vector. And shuffle is part of algorithm or something. I guess this is going to be that. That's a friend. Let's just use M resources. That doesn't look random at all. I mean, 4, 4, 4, 4. These numbers look random, but yeah, well, kind of random. 4, 7, 2, 1, okay. Yeah, okay, random enough. So we have 8 resources numbered 0 to 7, and I see all of them being used. 0, 1, 2, 3, 4, 5, 6, 7. And each of the threads want to have 4 resources. If we run it again, we get different numbers. Oh, it's just pure coincidence. Yep, okay, so that's good. It's they want 2 till 6 resources. So I already saw 2 and I see 6. And it varies and it picks whatever. Okay. That works. Right, then I think it's pretty random. Then now the algorithm. So the idea is that now each thread tries to get a lock on all of its resources. I guess we can brute force the order in which threads run. Or, I mean, either brute force it or just use a Monte Carlo approach and also do that randomly. I suppose that with I don't think we can brute force these amounts. It's just too much. So I probably should just randomly switch threads. What do you think? So we're going to run forever. We're going to run the thread T, and that is a random number. Between 0 and yeah, I don't know, maybe I should call it different. I can call it a random thread. A random thread, which is a uniform integer distribution for 0 till the total number of, or the number of threads. Till the number of threads. I think it's inclusive, isn't it? ABD, what do you think? This was inclusive, right? I mean, the 6 is generated here as well. Yeah. So then 0 till number of threads minus 1. So I'm going to run threads T. Just one step. No. Kind of randomly run a thread, one step, and then the next thread, etc. Okay, but this is going to return something. If it returns true, then we're done. Okay. Yeah, good evening, Tom. I think this looks good. We run the threads step by step in random order until one of them gets all the resources. I also want to count the number of steps. To be honest. So let's say this is put it outside the loop. Or not, I don't know. Int step is 0 plus step. No, let's start at 1. Some random def, well, mostly because I want the same thread to run a few times after another. So this may be a bit rare, but it's definitely a difference. And also every step is different, so you cannot just run them in order, then you do not get all the possibilities. This way you just get one possibility of the many ways this could do a race. This is my job. I mean, it's the only thing I do. Streaming on YouTube. Right, so this is our thread class, and I just added a step, a boolean step. We still don't have an algorithm to test, so this now is going to run our unknown algorithm, and I don't know how to implement it. I still don't know. I have to make something up. Okay, think of an algorithm. So, Abtenara, you seem to be knowledgeable. Please help me. You know what is the problem? Let's say each thread just locks the resource every time it accesses it before it does anything to it. We don't need a lock here, of course, but I could just call a function on one of the resources, and then I do not have to worry that another thread accesses that same resource at the same time, because I'm going to have it locked eventually. So let's say I have the following algorithm. I'm going to try to read lock. No, I'm going to... I need to have some kind of idea, damn it. Also, we need to test the test. So I want to start with this really stupid algorithm and then see that it fails. If this test cannot show us that it fails, then the whole test is wrong. It's not usable. First I need something that fails, and then I can improve the algorithm and see that then it succeeds, if you get what I mean. So just come up with the most stupid algorithm you can think of. I think we have a resource counter, initialize to 0. Okay, actually initialize it. And the algorithm is just going to tell that resource that it is now being used by us. Okay, so our resources are stored in resources. And now I'm going to say resources are acquire. And then we do ++r, and then the next step we acquire the next resource until we're done. So we are done when r reaches the total size. So if r equals m resources size here, return true, otherwise return false. And yes, I can just return this boolean expression, but this is anticipating that it's going to become more complex. Maybe we should reverse this. We say as long as r is less than the resource size, we do not have it yet. So false means continue running. And this means we have it. Looks good, right? Now, acquiring a resource requires that we pass an ID, the thread ID. And it must be unique, so I'm just going to pass this pointer, which is definitely unique for this thread. So then the resource class here has an void acquire with the thread pointer. But the thread must already be known, so I'm doing forward declaration here. And then we have we have at first I would say a thread pointer owner, okay, which obviously starts as a null pointer. Let me add it to here. So both is possible. Why not like this? Null pointer. It's even a little bit better, I think. This way we can call init again, and then we just reset it to null. Otherwise, it would only be null after the first time, and init would only work once. And now here we have the thread, which is acquiring it. So what we do is we set mowner to thread, and then it's acquired. But of course that doesn't work when acquire is being called by two threads. So which wins? Well, the first thread. This is a really stupid algorithm. So the first thread that calls acquire gets this one resource, and the second one doesn't. So I'm afraid that acquire also is a boolean, returning true or false. So if mowner is already set, then we return false. That's kind of like, sorry, but we are already acquired by someone else. And if otherwise, we return true. You will add support for releasing resources, or do all threads just try to acquire the assigned resources? They need to acquire all the resources, and only when they get all of them, they can continue. And there must only one thread succeed. So now each thread is just acquiring one resource at a time, and it would be dumb luck if it would get all the resources. Because as soon as any other thread gets one of its resources before it gets all of them, we will get a deadlock. And I hope to see that, because I really want to start with something that fails. So what happens here is that if acquire, where do we call acquire? If we do step and the acquire fails, so acquire is false, then we could not acquire that resource. Therefore, we failed. Failing in this case means that we just, give up, right? Yes, of course. Like I said, I want to start with an extremely dumb algorithm, so I can see that it fails. There is no undefined behavior race condition, because like I said in the beginning, we can assume that I'm taking a mutex before accessing any resource. So the call to acquire, the thread locks this resource, and then it calls acquire. So there is always only one thread calling acquire at a time. That's my assumption. Now this boolean is not sufficient anymore. We have 3 possible values, namely keep running, success, and failure. Now failure is not really an option. If you fail, then I think we have to just release whatever we acquired and then start over again, right? Well then, if we do that, then by dumb luck, sooner or later, someone succeeds, of course. And the fact that that's by dumb luck, it's not going to help to use Monte Carlo. So I'm afraid we need true brute force and just try every possible permutation in which the threads can run. And then we will find that there exists a permutation in which the threads are run that never ends. But that means that we probably need to restrict the number of resources and the number of threads severely. And then hope that if we find an algorithm that works with that it still works with a larger number. I think anyway, if this happens, the acquire fails, then the algorithm failed, and I cannot imagine that there is any other solution than to completely back off, because if this thread can't get all its resources, then it might be blocking the thread that can. So it might better just back off and say, well, okay, then I'm not running. I lose. I stop. So at the very least, it should unacquire everything, which I think is always possible. So I can just do that in a for loop. or not. So we do a step here as well. It's probably necessary. Could be necessary. I'm not entirely sure. Just know that if I do this, if I make this a step as well, then of course the brute force is going to explode. It's a bit too easy. I'm gonna start like just, I don't know, unacquire all of them. Call it release. And now we keep running. So I start over with R0. So the next time it just tries to acquire the first resource again. Then I have to implement the release. Yeah, it's not trivial at all. I have the feeling. Okay, so we just release it again and then we start over. So I think that it's going to succeed, but only with dumb luck, right? Maybe I can keep using Monte Carlo and just increase the number of resources dramatically. And that should make it very slow. It still would succeed with dumb luck. But let's say I increase the number of resources until it takes a whole minute to get it with dumb luck, and then I consider a whole minute a failure. So then we improve the algorithm until it succeeds in a microsecond. Let me see if this compiles. There's no acquire in unreadable, which is a pointer of type unreadable. Oh, that's a pointer. Yeah, okay. Why didn't you tell? Why didn't you say so? M resources contains pointers. Huh? No. Not that one. Contains resource pointers. Expected semicolon before. I missed. I'm missing a lot of semicolons. I guess plus R2 is also missing here. Ridiculousness. And my keyboard is not very fast with the shift key. When I let go of the shift key, it takes a while. So often I type the wrong character in. Thread 1 did get a log on all its resources after 9 steps. Maybe I should also print yeah, that's 33 steps, you know, I don't know. But let's start with printing what I did before, and I should not have deleted it. Just print for all the threads. Print all the threads. So we can see what it is. Ten steps. Well, let's print the thread number in front of it, as if we cannot count. Thread 2 did get a lock on all its resources after 38 steps. That's a lot of steps. Yes, 5 and 6 is more normal, I guess. Let's see if we get one that gets over 100 steps. That's probably very unlikely. $65. You can also just restart it, I guess, until the number of steps is 100. No, 94. Well, that's close enough. Oops. Yeah, can also look for outliers. So let's say the number of steps. You cannot do that, I think. 2. Segmentation fault. I'm using Arch. Why did we get a segmentation fault? This is 0. Length of 3. Why is it passing 4? For a vector that has a size of 3. I'm starting over without resetting R. Yeah, that's what you get when you don't have an init. We do have an init. Am I calling init again? I don't think so. No, I'm just blindly starting over. I need to include all of this, I guess, inside this loop. Now I am calling init. Well, I don't want to print this every time. Let's just print it when we get to this point. Now we're calling init, so it really is different every time. And then init must reset D as well. Reset R as well, I mean. Now I have an R here. Let's call it MR, whatever. One more. Holy, and yeah, right. 358. I mean, whatever, but directly after 21. That's not going to happen again. And now? Oh, this is even better. Yeah, I think it deadlocked. Well, that's sad to have a boss like that. And then it's hard to react, right? I mean, normally you would just say you should keep up. You should keep up to date with the latest standard. But since it's your boss, you cannot do that. So what are you going to say? I think the reason is, by the way, that I do not reset the acquirements. So the whole reset, let's make a reset function. And I'm doing a reset here when step. This is basically my my reset. Well, if reset resets MR, then there was no need anymore to do it in the init. But let's keep it in the init anyway. resource is not defined here. What? Oh, I added to the to the resources. I meant to add it to thread, of course. Now I think about it, let's put it below the printer, or maybe just move the printer down. So the reset is just above the step. Seems to be more logical. And then let's run this and we get again a deadlock. What the hell? Okay, I really don't get it. Why? How is this possible? Because I'm still not resetting it? That must be it. Adding a reset and then not using it. I guess the init must reset. Oops, that's not what I wanted. Array, total number of resources. Yeah, we have to reset before the... Now I'm gonna delete this. Okay, I'm an idiot. What am I doing wrong? It clearly does not have a clean start. So this runs once correctly, then we get at the bottom of this while loop, we go to the top, and I want to do a 100% clean start. The number of threads has not changed. It's even a constant. I call init on each of the threads. Resources has not changed. After this for loop here, everything must have been completely reset. But that is clearly not the case. Oh, I'm an idiot. I do push back, so my reset should also clear my resources. Now it's totally reset. Resources cleared, MR set to 0, and we released all possible ownerships. Why the hell is it still hanging? And why do I suddenly get empty things here? Okay, this is getting out of hand. It's not funny anymore. Let's forget my while loop. Going to add a return 0 here. And then see if I still get the empty things. There, empty. This is empty. Yeah, but that should never happen. Why is that? happening? Oh, that is happening because I'm now printing it here. Threads T. No, I'm getting it. I'm being stupid. I get it. It should not be, the reset should not be done, the clear should not be done in the reset. Because the reset is also called from here. So if the acquire fails, we want to start over without clearing M resources. So then I do my reset, which releases all ownerships and start from the beginning. But M resources is left alone, obviously. And when we re-init, then I also call reset because I want to clear all the ownerships. But then also we have to do a clear. I think now finally I have it correctly. Yeah, that works again. And now remove the return 0 here, and then I hope finally 104 steps, 110, 122, there we are, 343, and it's very fast. So let's make this 1000. Okay, clearly the chance that the number of steps gets over 750 is pretty small. Very small. I feel tempted to wait, however, even though it takes a long time. 922, okay, so I have seen enough. Well, you believe that program is not reacting to... Oops. Okay, well, we reach 500 pretty damn fast. Man, what am I doing? I want to go here. So let's put 500 and call it a day. That is... we should never reach 500. So we reach 500 and thus the... algorithm is a failure. Okay, so now let's improve the algorithm. Okay, need ideas. We have failure because the number of steps blows up. How can I improve this? Well, if you keep clicking on it, poor Shinky, they think that you like it. Step tries to acquire a resource. Well, I'm totally open to listen to the chat to give me ideas here for this algorithm. I had an idea. I mean, and I went off stream and I said I'm gonna lay down somewhere and think about it. I did have some idea, which involved each thread just tries to register itself for a resource instead of locking it. Let me think. Well, we have a waiting mechanism. So it must be possible that this thread returns that it backs off until it is started again. Let me add an enum. Step result. Okay, I return back off here because I just let the other thread win. So whoever already acquired this gets the priority. But yeah, that means that we do not want to be called anymore. So I'll make a bool running. Now, in the ideal case, I would not generate random numbers anymore for threads that are waiting. So what I could do is really swap non-running thread to the end, and then decrement the largest number that is being returned by a random thread. So I really need a vector of uniform int distributions then. I'm not sure if it's worth it to try to save CPU like that in this test though. I'm not sure how slow it will get, so let's just burn some CPU and that's calling a random thread until I get a number that is running. So just generate a random thread, but if that thread isn't running at the moment, then we generate another random thread. So now we only call step for threads that are actually running. I don't think I get what you're meaning, Abd. Outgoing flow? What is outgoing flow? Network flow will work. Oh yes, absolutely. Hi, Retin. This is leading to a deadlock, but you got to start somewhere. I'm going to pass threads to this function, I think. Sorry, it's the other way around. It's not like this. Success. And then else if SR is back off, we don't need to do something, probably. Okay, passing threads to step. Yeah, it's not working. Damn it. Making it too difficult. Okay, let's say we have two number of running threads. If one extra thread backs off, then the number of running threads is decreased by 1. And then it's pointing at the last one that is running, and I want to swap this thread . Yeah, I need to know, then I need to know the number of this thread. Is that not simply known already? MR? No. Changes continuously. Anyway, this pointer is a reference to the array, isn't it? Yeah. This puts the current running thread over the last running thread and decrements the number of running threads. Now I guess here I'm just going to use my the percentage trick, because otherwise it gets a little bit too silly. And I'll just make a random number thread generate something large. The init should set it to running as well. Yep, it does. So now if the acquire fails, it also stops running. Just really will not run anymore. Which I can assert by checking that if step is being called, then M running must be true. Alright, if it is backing off, then currently I just don't want to do anything. It just stopped running. Deadlock, okay. Should be possible to get an immediate deadlock, or maybe even, yeah, okay, better. So I get 3 things and then a deadlock. I just want to see a deadlock immediately. Should be possible. Yeah, deadlock immediately. Okay, so it looks, I think it works, right? Well, also note that now the number of steps until the deadlock is pretty small. I've seen 16. Now the largest number of steps that I saw was 16. Not 500. But deadlock is not good, of course. So we need to get those threads that are stopped running. We need to get them to run again, and they're backing off because of a certain thread. So we do step, try to acquire a resource. If that fails, we back off. We permanently back off. So what I want is to register ourselves as being backed off with the thread that already owned it. So we call acquire, no, not like that, acquire, and owner is already set, then we are going to back off, but I also want to tell the owner that we back off. Or, which is maybe even better, we queue ourselves here. Let me think. Can make a first in, first out queue here and then just push ourselves at the end. Hey, that seems like a good idea actually. That seems like a good idea. How about make a first in, first out thing? That is simply a queue, right? So it's a standard DQ. Oops, comma type DQ. And then owner is the one that was pushed first. Init means now clear. And this becomes if owner means if not empty. If it is empty, we return true, but in all cases, well, it doesn't matter. Let's just push it back to owner and push back thread. That's then the first element, and we return true. So, well, there's a cleaner way to do this, right? Boolean first. We are first if owner is empty. Well, then I just always push back, and then we return true if we were the first one. I'm programming a test application that does a not a brute force but a Monte Carlo approach where a number of threads try each to get a hold of a number of resources which partially overlap. So just generating a number of resources for each thread, and then each thread tries to get all the resources. The whole program is just a few pages. So if this thread here tries to acquire this resource, see, this is a class here, member function acquire. This thread's trying to acquire this resource. If there is no owner yet, then the resource was not acquired by anyone. So we push ourselves back as owner. We acquired it, and then we return true. If it was already owned, we push ourselves also back, and then we return false. Now release is different, I guess. Release means do we still want to release? I think that the way that I call release now is kind of like if I acquired it, then release. And I only acquired it when it was first. Meaning that we are at the front. So if owner is empty, there is absolutely nothing to be done. Just return. Otherwise, if owner front equals us, then we remove that pop front. Possibly making it now empty. Now, any thread that called acquire that was not first did add itself to push back and return false. And by returning false, it did reset, stopped running and did back off. So now I want to wake those threads up. No, I want to wake just one thread up. And that is the one that is now in front. What the hell is reset doing again? Damn it, that's not working. Reset is calling release on every resource. Oh, that's complex. That might cause an avalanche of recursive calls, no? Now this file currently has 194 lines. I'm using NeoVim. Reset. Starting to be confused as well again, even with a simple program like this. It's just so small. If not empty, if still not empty after popping to front, I'm now going to tell the new front that it should run again. Just simply run again, right? So like run again. Fortunately that's not possible because front is a thread pointer, I think. We don't know threads yet. Threads are defined here. So I'll have to define that below. And then we can add a run again function. Now this of course means that we should not be running, or something is wrong. And running again means that, well, we kind of have to do the same thing as we do here, but then the other way around. So I also need to know the number of running threads here. So the number of running threads, I need also the array of threads. Probably should just make it a global word. Okay, that's too much. I'm not going to pass that everywhere. Let's make these globals. Okay, it is not working. Die. Stupid spam bots. People have such a low moral that they run spam bots on random YouTube channels. They are probably scammers, right? I mean, they don't have any ethics. They don't have any moral. They just want money and they don't care about other people's feelings. So if you would go to their site, they will probably ask you for your credit card number. 1% will be so stupid to think that it is legit. Give the credit number to prove that they are 18 years old. And woof, weg. Gone is your money. Never believe people that are making advertisements like this. It's never true. Filthy scum. I said one Dutch word. Sorry. This thread is trying to acquire this resource. If it is the first thread to acquire it, it returns true. In all cases, it pushes itself at the back of the queue. Okay, let's go top down the thread. Every thread wants to acquire certain resources. These are the resources that it wants to acquire. This is the resource that it wants to acquire next. This says if the thread is still running or not. If we start over, we will call init on every thread. Every thread will be told how many resources it should try to acquire. And it gets a list of all the existing resources. And a random number generator. So it can pick the number of resources at random from the resources that are being passed. The thread is being reset. What does that mean? That means that on every resource that it had before, and the first time this is empty, so it's not doing anything, it calls release with the pointer to itself on the resource. That doesn't work. Yeah, this reset here is nonsense. I can just say clear resources. But then I have to set MR to 0 as well. So a reset on thread means that this vector is emptied, MR is set to 0 and M running is set to true. Totally. Next we create an array filled with the numbers 0, 1, 2, 3, 4, 5 up till total number of resources. Which then are shuffled, and then we get the first number of resources from that shuffled array. Convert that to the pointer to the corresponding resource and store that in our M resources vector, which only contains pointer to the resources. So that works. At the moment that init is called, I also want to reset the resources themselves. It means that init must be called on all the resources. Init is currently called here, and when we start over, we do not init that again. That's probably not a good idea. Therefore, let's delete this and put it here. So now every time threads are initialized at the beginning of a new run, we call both init on all the resources as well as on all the threads. It should not be necessary to pass the resources. That would be necessary if we need the old resources. Resources. That's not true. We need pointers to the resources. So yes, it must be passed. So the resources are initialized first, and then we pass it to threads init because we need the pointers to those resources. Everywhere else I'm using an R to run over the indices of all the resources, so let's do here as well. And let's have a look at what that exactly does. It just clears on and set an ID. Okay, so that's 100% reset then. And this one worked as well. A reset on a thread is going to be called when it wants to start over without reinitializing itself. So starting over, it sets MR to 0, meaning it's going to try to acquire MR index number, resource number 0 first. And if it had already acquired anything, then it's releasing that acquire. So it runs over all the resources that it might have attempted to acquire, it was trying to acquire, and run release on it. This release function does the following thing. If nobody has acquired it, we do nothing. If the front is us, then we do something, otherwise not. So we only do something when we are at the front. And what we do is we pop the front, so now we do not no longer at the front, which means we do no longer have acquired it. If at that moment the owner is not empty, we tell the next front that it can run again. Which is true, because the one that came after us in the queue, in the D queue, must have backed off and is not running again. Not running anymore. I think that definitely should. Seems correct. Okay, so if it is running, that's returned here. Are we even using that? Yes, I'm using it. Although I don't think that's correct. Should not need it. Okay, step is being called when this thread must run for a little bit. Run again is called when we want to do the opposite of backing off. This prints something. These are the threads that we have. The number of running threads, they must be initialized at the top of our for loop. So yes, initialize resources, threads, the number of steps, and the number of running threads is reset to total number of threads. And then we begin the real test. And here I start over. Okay, looks good. Resource release, I just looked at. Thread step. Step may only be called when we are running. We try to acquire the MR resource by calling acquire on that resource. This returns false if it fails. That causes us to call reset, which means we're going to start over, but we also back off and we stop running. This is done by decrementing the number of running threads, which might become 0. Definitely larger than 0 at this moment. Should I add an assert for that? Probably. Let's add an assert. Just in case assert. So say there are 2 running threads. 2 threads are running. Number of running threads is 2. Then it becomes 1. Which means that is now the index of the last running thread, and then we swap ourselves with that thread, which means that now we are at position 1 and only index number 0 is the only running thread. And if these two are equal, then it's trying to swap itself with itself. I'm not 100% sure if that works, so let's just not do that then. If this is unequal, do that thing, then swap it. Otherwise, don't swap it. Hello, ambient. if it did succeed, acquiring resource MR, then we're going to acquire the next resource, the next step. Unless, of course, MR became equal to the number of resource size, then we succeeded in getting all of them. And otherwise we just keep running and step is going to be called again. If we did back up and at some point the resource that we were waiting for is now released, then the run again is going to be called. This may only happen when we were not running. It is running is set again, the number of running threads is incremented, and we swap ourselves again. And let's again do this only when they are different. Can't type. Also my keyboard is, what is it? Eroded so much that a lot of keys are not readable anymore. This is unequal, same thing as here. The scammer is back. He just wants to steal your money. So I think that after this, we are just running again. And then the main thread, that's the last piece code to look at, but also the largest. Well, the top is just random number stuff. We have an array of resources. Max steps begins at 0. Number of steps is initialized here. The initialized resource thread steps set to 1. Number of running threads is maximum. We start running. What we do is we generate a number between 0 and number of running threads. And the way it's working now, that should always be a running thread. So we call step on that thread. Step might decrement the number of running threads. Now no thread is running at all anymore, then we have a deadlock. If SR is success, then we finished, which means we break out of the for loop and we just reset everything and try again. And if number of steps needed was larger than the previous maximum, then we just print that is the case. Well, I did make a few changes, so let's hope that now it works. And it didn't. Same assert. How is this possible? I want to know if we can get an abort without the first success. Yep, that's possible, apparently. Well, I guess I'll just have to run it through the debugger and see what the hell is happening, right? Why would I do that? A deadlock. Well, I want to see a crash. I want to see an immediate crash. Again. Deadlock. Oh! What's that? Yeah, this one. I don't think I need the random number device at all. So now I can reproduce it. Oh, except that I typed twice NTF. What? Okay, so now I can reproduce it. So run again is called while I'm running is already true. That's really weird. That is weird. Why would that happen? That's of course still the maximum. SR is of course success because we were the no, it's not success. I mean keep running because we were the first thread. That was one step. Generate the next number. This time we run thread number 2. Yeah, I think in the end, just debug output. Nothing can beat debug output. I just have to print a lot, I think, so we can see from the output what is going on. Yeah, that's recursive. Maybe it should just print an ID or something. So let's have every thread should have an ID. Print thread. Well, let's have a look if this even compiles and runs. Not make. Of course it does not compile. Never compiles the first time. I think I have once every 2 years a case where it just immediately compiles. Threads was not declared in the scope. Did you mean thread? No, didn't. 6.8. Number of threads, yes, that is what I meant. That is true. Okay, so if the printing works, it says it prints resources first. Let's print that it is printing the resources. Why? Okay, so let's start over. See out resources. New line. Okay, I give up. Then like that. Then let's see out threads. Yippee. Okay, reset everything. Resources. Yeah, the ID is equal to what I print at the front and owner is empty. Threads. The threads want to acquire resources that are listed. And they are listed the same as above. I am not printing if they are running or not. Maybe I should do that. Threads. I'm just printing threads, so that is operator less than. This only prints the resources, but we have more than just a resource. We have an ID and we have MR and we have M running. Well, I'm going to print everything. Now S MID equals MID, and then we print. Well, then we print resources. Okay, M resources. Let's put angle brackets around it, just because. Oops, and then we get MR, and then we get M running. And then we're done. Bool alpha requires IOM. Of course, it's not that time of the year again. That's why I like to use print on. Maybe I should switch. I should add that as well. AE.out. So now it's printing. Same thing as here. The ID is obviously the same as we printed at the beginning. M resources equals 2. Well, one of the resources are 14260, whatever. Running is true. Oh, MR is 0 and running is true. I'm completely happy with this one. Then we get MID1 resources. Well, 21405 angle bracket close. MR is 0, M running is true. And then we get resource 20531 angle bracket MR is 0, M running is true. And then we get ID 3 resources ID 3070. Sorry, 7 and then angle bracket close and multiply. Perfect. But we crash. So we need more debug output because somewhere M running has become false. So what is happening after all this printing? The rest seems not relevant, so you just have to add debug output to step. That is all the inside acquire, I think. Yeah, Gizmo, I type std in front of everything because I want to see if something is part of the standard. I like really long names so I can grab for it. It is the only, and then I mean the absolute only disadvantage is that you have to type more. But I don't care about that, because the benefit is that the variable names are longer, and therefore regular expressions work much better. Plus, you see immediately which things are written by me and which are from libraries. So I see here M owner, there's no std in front of it, therefore it is part of my program and not part of the standard library. And that holds for every library. I just seldom use using namespace. Yeah, it's definitely the right music, because that's what this is. This is a boss battle, where I am the boss, of course. Okay, printing. Yeah. This is maybe going wrong. Yeah, this indentation, I don't know. I'm gonna do an indentation, but use English sentences, capitals at the beginning and periods at the end. Today a lot is happening. So we set everything, resources, threads, 4 of them, number of threads 4, number of running threads. Running thread 0. Thread 0 is trying to acquire resource 1. Success! Owner now contains 0. Yes, that's true, because 0 is now owning that thread. There is no new line here. Well, this is just missing. Going to add it. Number running thread is 4, so owner now contains 0. Setting mr to 1 because it did get 0 and next we get one more as 1. Running thread. So it's trying to get the resource 1 because this is what? Thread 0 has the resource 1 is the first one, resource 4 is the next one. But first we are running thread 2. Thread 2 is trying to acquire resource 2. Thread 2 trying to acquire resource 2. Success, owner now contains 2, setting mr to 1, running thread 3. Thread 3 is trying to acquire resource 3. Success, owner now contains 3, setting mr to 1, running thread 1. That should get 2 and that is going to fail. Thread 1 is trying to acquire resource 2. It fails because thread 2 already acquired the resource. Thread 2 is trying to acquire resource 2 as well and succeeded. Owner now contains 2, 1 because 2 did get it and 1 added itself at the end. Running is set to false, after which of course everything still looks exactly the same except running is set to false on thread 3. Well, that's weird. So I have a true, true, true and false, but it is set on the ID 3. Oh yeah, of course, it did swap to the end. Oh, now I see what the problem is. I'm using the index here to get the right ID. That is not working like this. So when I want ID 3, I'm using this one, which has ID 1. Yeah, that's not working. We need an indirection array instead of swapping it. Let me think. All this work. Yeah, let's give it a name. cannot swap the threads. Got to swap something else. How shall I call it? Let's call it running ID to ID. And that's kind of nonsense, and I never use abbreviations except in small test files like this. It's not a real application, this. Just a quick hack, and then I'm okay with abbreviations that mean nothing. Well, it kind of has to be filled with 0 till whatever every time I'm initializing threads, I guess. And then I'm going to use that here. This is more like a running thread. Let's call the running index. And then we're going to run thread number running index to ID, which is vague as hell, but I think that works. And then we're going to swap well, that's a good question. What are we going to swap? Yeah, that is not easy. That is, I can quite easily pass the running index to step, but I have to swap it again here. Man, it's giving me a headache. Let's start with the step. Asking the RI. I think I did not explain that very clearly. Let me explain it. The idea is as follows. We now have an RI to ID, which starts off with 0, 1, 2, 3. Within the index, and then it contains 0, 1, 2, 3, which is the index, into threads, which has the index, sorry, the ID 1, 0, 1, 2, 3. Now suppose this thread here, all threads are running, and thread number 1 wants to stop running. Then what I do is I swap this one from this array. Sorry, this is yeah, this is the index into this array, and it contains indexes into this array. Now if I want to stop thread number 1, which obviously has ID 1, then, but this is the content of that array. This is super unclear, right? Sorry, let me try to make this a little bit more clear. Guess we can just do away with those. So this is the index into threads as well as the ID of the thread. It's the same thing. And now I want to stop this thread from running. I swap the contents of this array now. And I swap the one that I want to stop running. So this one. I swap it with the last one that is running. So I have the number of running threads equals to 4. I decrement that to 3. And then I swap 3 with 1. So that means that this becomes 3 and this becomes 1. And now the number of running threads is 3. So I'm going to generate a random number between 0 and 3. So 0, 1 or 2. And then the actual thread is then 0, 3 or 2. Because it's not 1, because 1 is not running. Let's say next I would want to stop thread number 0. Then I swap 0 with the number of running threads minus 1 is now 2. So I swap the 0 and the 2 here. So this becomes 0 and this becomes 2. And the number of running threads is 2. So now generate a number under 2, 0 or 1. And then we get, reading this array, 2 or 3, because 2 and 3 are the only threads that are still running. Let's say at this point I want to start running 1 again. Then I increment the number of running threads from 2 to 3, and then we swap this one with the third thing. So I swap 1 and 0, and the number of running threads is now 3. So next we generate random numbers 0, 1 or 2, and now we get 2, 3 or 1. So it's at all times it is split up in the running threads up here and the not running threads up here. Now I want to stop thread 3. I swap this. Sorry, the last running thread is 1, so we want to stop 3. Let's set the 1 here and the 3 here. And decrement the number running threads. So these are the running threads and these are not running threads. So the swapping is done in order to get all the non-running threads at the end and all the running threads at the beginning. So now I have the RI, so it's the running thread index is running. And the actual thread that is being run is the ID of this thread, MID. And to make this thread then stop running, I decrement the number of running threads and I swap in the RI to ID array the running index with the decremented number of running threads. But if I want to go the other way around, what you have to do here in run again, now you have to do the exact same thing, except I don't know what RI is. I think I'm just going to do it by brute force. So I run over all the RI. Let's begin at the end. I just try all the RIs until RI2ID contains MID. And then we swap it. That should work. And there is no need to continue after that, of course. Still cordums. Well, it did run for a while longer, but I might as well just go to the point where it's reset everything. So here, resetting everything. That was the last point, right? And then see what is happening now. Resources look good. Threads running is true, running is true, running is true, running is true. Number of running threads 4, running thread 2. Thread 2 is trying to acquire success. Only now contains 2. MR is set to 1, running thread 1, thread 2. It fails because it's the same resource. It fails because thread 2 already acquired the resource. Yes, M only now contains 2, 1, setting M running to false, after which, and now we should have, this was thread 1, so thread 1 now is not running. That's correct, the other threads are still running. Now we do running thread 0. Thread 0 is trying to acquire resource 5, success, M only now contains 0. Setting MR to 1, running thread 0 again. Thread 0 is trying to acquire resource 2, I believe that, you know. Success, M only contains 0, that's where resource 2. Running thread 0 again, well, starts to become unlikely. But possible, trying to acquire resource 4, success 3, running thread 2. Two is trying to acquire resource 5 because it already owned 0. It fails because thread 0 already required the resource. Yep, up here. Now we have 0, 2. Setting I'm running to true. Well, that's interesting. It fails to get it and it sets I'm running to true. What the heck? I guess this is part of the reset. So I should start using libcwd because I don't see what the indentations are a bit, you know, vague. Not working is another word. Oh boy, it's 1 AM. I should go to bed. Yeah. I'm disappointed, man. Why is this not? Why is this holding me up? So annoying. But yeah, and yeah, and I cannot finish it. It's more difficult than I thought, and it's too late now. So I'm going to continue tomorrow. Maybe I'll see you then.